Today we are going to discuss about free fall. This is the next topic from the chapter gravitation of class 9th. So free fall, it is falling from some height, is it? We know that every object that is thrown above the surface of the earth will return back after some time. Nothing will fly away, everything will be returning to earth due to the force of gravitation or gravity of earth. And whenever objects falls towards the earth under only gravitational force, we are considering only gravitational force, we are not throwing, it is just falling, and the force acting upon the object is only gravitational force, then we will say that that object is under free fall. So under free fall, the force that acts on the object will be gravitational force only. There will be gravitational force only. Okay, then due to this gravitational force which is directed towards the center of the earth or directed downwards, what will happen? The object will reach the surface of the earth, and what will happen? Its velocity will change. Am I correct? Its velocity will change, and as there is a change in velocity, what will happen? There will be an acceleration also. There will be an acceleration due to the change in velocity. Okay, but okay, let us consider there will be an acceleration. Okay, then but here the direction of velocity is not changing. See, the direction is downwards only, so there is no change in direction, but the magnitude of velocity is actually changing. Then let us see how this acceleration varies, whether it increases, whether it is uniform, whether it is a constant acceleration. Let us see. Okay, so for that, the general formula for force, that is F is equal to m into a, that we have already studied in lower classes. Suppose an object of mass m is falling towards the earth, and if the mass of earth is capital M and this distance is d, we can write the force as F is equal to, this is actually gravitational force, that is G m by d square. Here I have not used m1 and m2, I have used m and m, small letter m and capital M. Okay, so this is the general equation for any force, and here the force is gravitational force, so we can write like this. Okay, actually these two are equal, is it? And we can, let us equate these two. Okay, force is on the LHS, let us equate the RHS. So we will get m into a is equal to g m by d square. Okay, and here small letter m is there, here also small letter m is there, so what we can do, we can cancel it, is it? M and m will be cancelling, and we will get acceleration as a is equal to g m by d square. So this is the acceleration. Okay, and if this object is very near to earth, okay, very near to earth, or if the object is on the surface of earth, somewhere here like that, what we can say, this d is almost similar to capital R. Actually we have to consider the distance from the center of the earth. Okay, this d means actually it is the distance from center of the earth, we have to measure it like that. Okay, then this d can be approximated to capital R. Suppose the object is exactly on the surface of earth, this distance will become exactly equal to R. When it is little bit more than, we can consider it as R only, because when we compare d and R, this d will be actually very less than radius of earth, because radius of earth is a large distance. Okay, so let us replace this by gm by r square. So acceleration can be written as a is equal to gm by r square. So g is a constant, universal gravitation constant, M is the mass of earth, that is also a constant. R is the radius of earth, that is also a constant. When you substitute the values and calculate, you will get this value as 9.8 meter per second square. 9.8 meter per second square. So, I told that there will be acceleration due to the change in magnitude of velocity, and that acceleration is actually a constant, means there is an equal change in velocity in equal interval of time. Is it? That is called uniform motion that have uniform acceleration. So acceleration is a constant here. Okay. So under free fall, the object will experience acceleration due to gravity only, and that is a constant. And one more thing, when we compare the shape of the earth, it is not a perfect sphere, that everybody know. It is not a perfect sphere. It will be of shape something like this. We will call it as actually geoid. And when you measure the radius to calculate the acceleration, from the equator we will be measuring the radius like this, and from the poles means we have to measure the radius like this. To the poles the radius is this much, and to the equator, or if we are measuring from the equator, the radius will be like this only. Okay, is it RE and RP? From the figure itself it is clear that this RE is greater than RP, means radius of earth will be greater at equator and it will be less at the poles. Okay, then one more thing, this A is used to, acceleration is actually represented by small letter g. Acceleration due to gravity is represented by small letter g, that we have already said. Then when we substitute this RE and RP in the equation of acceleration due to gravity, and this R comes in the denominator, is it? R comes in the denominator. So when R is greater, as it is in the denominator, G will become smaller, is it? When we divide a number with a bigger number, the result will be a smaller number, is it? So when R is greater, G will become less, and when R is smaller, we are dividing a number with a smaller number. So our result also will be almost somewhat a bigger number. Okay. So here RE is greater than RP. So what will happen when you think like this? RE is greater, is it? RE is greater means G at equator. G at equator will be less or high? It will be less, and acceleration due to gravity at the poles will be more. There is no bigger difference actually, slight difference only in decimal points. Okay, there is no large difference. Then, so you have to understand that GE is less, and G, acceleration due to gravity at the poles, will be greater. Okay. And one more thing, later we will learn that in the same chapter what is meant by weight of an object. So you will see that weight is equal to m into g. We will learn it later in detail. It is m into g. So that is our weight, is it? And when we go to the poles and measure our weight, what you can conclude from this information? When as the GP is greater, you will experience more weight when you go to the poles. And when you measure your weight from the equator, you will experience, or you will get a less value, is it? So we will learn it later. A difference between weight, mass, etc. later in another video. Okay, thank you.